Hi guys. Today is the first day in Algebra 2 that we're not going to learn a new type of factoring, but we're going to actually put it to use today. So the topic is to solve by factoring. Our essential question is, how do we solve a quadratic or cubic equation by factoring? And our second essential question is, how do we know how many solutions we should get? Because there is a possibility that you have more than one solution. So how do we solve a quadratic or cubic equation? By factoring. And the second one was, how do we know how many solutions we should get? Well, that's not how you spell that. Okay. So, to solve a quadratic equation by factoring, it must be in standard form. Standard form is y equals ax squared plus bx plus c. That's the form that we talked about when we factored by grouping. We were trying to find magic numbers by multiplying a and c and finding something that adds to be the b value. So it must be in standard form, and you need to set the equation equal to 0. So sometimes your equation is going to equal a number, sometimes it's going to equal y, but you need to take this equation, you need to set it equal to 0, because this is how we find our solutions. The second step is to factor the equation, like we have done in the past, and be sure to check for a GCF. So factor, and always check for a GCF first. Once you factor, you want to set each factor equal to 0 and solve. So you're going to have a few, usually 2, sometimes 3, little tiny mini equations where a factor is set equal to 0 and you can solve for your variable there. So if you look at your problem, if you have x to the power of 1 or just x, that means that you're going to have one solution in your answer. If you have x squared, that means that you're going to have 2 solutions. And if you have x cubed, that means that there are, you guessed it, 3 solutions. So let me show you what those look like. If you have just x, or x to the power of 1, that means that you're going to end up having something that on a graph might look like this. And the solution would be the place where it crosses the x-axis. If you have x squared, then what that looks like graphically when you find your solutions, remember x squared means that you have a parabola. So you've got 2 places where the graph crosses the x-axis. And finally, if you have x cubed, graphically what that looks like is it looks like a graph that comes down and then up and then goes back down. Or perhaps it starts going up and then down and then back up. So you've got 3 places where the graph crosses the x-axis there, meaning you have 3 solutions. So graphically, that's what they look like. We're not going to talk very much about graphically today, but I do want to go through some problems with you and show you how to factor in order to solve. So first example, switch back to my colors. I need, step 1, I need my equation to be in standard form, ax squared plus bx plus c, and it needs to equal 0. Right now it looks like I have ax squared plus bx equals something. So I want to move this 6 back over to this side. So in order to do that, I want to do the inverse. So this changes to 3x squared minus 17x minus 6, and that equals 0 now. So this is in standard form. I have A, B, C, and then I have my entire standard form equaling 0. So this is looking good. So step 1, done. Step 2, factor. This needs to be checked for a GCF, and I don't see anything that I can take out of 3 and negative 17 and negative 6. So I'm going to go ahead and find my magic numbers. I need two numbers that multiply to be 3 times negative 6, so that's negative 18. And those two numbers also need to add to be negative 17. Well, I think if I list out my factors, 2 and 9, 3 and 6, and I think that's it. If I list out my factors, I notice that these two have the potential to be my magic numbers, but I need to change my sign up. So if I have a negative 17 as the sum, that means the 18, the larger number, needs to have the negative. So this is, instead of a negative 17x, we have plus 1x and minus 18x. I still have my 3x squared. I still have my minus 6, and it still equals 0. I need to factor by grouping, so I'm going to group. Take out my GCF of each group. Here, my signs need to be changed. I'm leading with a negative coefficient here, so I need to divide by negative something. Negative 6 ought to do it. This is all still equal to 0. And then my factors are 3x plus 1 and x minus 6. And if I multiply them, it should equal 0. Now, it's not in your notes, but there's something called the zero product property, which means that when you multiply two things together, like this factor and this factor, if you're multiplying them and you're getting an answer of 0, that means at least one of them's got to be 0. So that's why the next step is to set each factor equal to 0, because either 3x plus 1 is equal to 0, or it's possible x minus 6 is equal to 0. Both of those situations would make this true, would make the product 0. So I'm going to solve each of my tiny equations. This one's easy. X equals 6. There's a solution. And then here, 3x equals negative 1. If I divide by 3, I get an x value of negative 1/3. So my solution is a set. I'm going to open up my braces. I'm going to list the numbers from smallest to biggest, because that's just the way you write your sets. It's the way you organize them. And this is my solution set. All right. Oops, sorry. Let's try number 2. Number 2. I have my equation equal to 0. It kind of looks like standard form. 2x squared plus 4x could be plus 0 equals 0, so that's standard form. A GCF, I see one. A 2 and an x can come out. So we have 2x times x plus 2. And it doesn't look like I can factor anymore. So taking out my GCF actually took up my factoring step as well. So now I'm going to set each of my factors equal to 0 and solve. So either x equals 0 or x equals negative 2. These are my two answers in my solution set. Perfect. All right, number 3. Ooh, what do you notice about number 3? It looks like it's almost in standard form and it equals 0, but I notice that we can take out a GCF. Not just of 2, but of what? 2x. So what I'd like for you to do is pause your video, take out the GCF, factor, and see if you can find the solution set. Pause your video and check back for the answer. All right, folks, number 3 is an example that has an x cubed in the original problem, and that x cubed indicates that we're going to have 3 solutions. So here are all 3 solutions. Don't forget to take your GCF and set it equal to 0 as well. If your GCF is just a constant, if it's just a number like 5, when you set 5 equal to 0, that's not going to make any sense. So it's not going to give you any solution. So you can kind of ignore those. So check your work. Make sure it looks good. Number 4. First thing, make sure it's in standard form. Ax squared plus bx plus c. It does look like we're missing a plus bx, but that's okay. The equation does equal 0. Go ahead and check for a GCF. What's the GCF? GCF is 2. So 2 times 4x squared minus 9. Well, that looks like something. Looks like the difference of 2 perfect squares. So off to the side, square root of 4x squared is 2x. Square root of 9 is plus or minus 3. So I have my GCF. I have a factor of 2x plus 3. I have a factor of 2x minus 3, and that still equals 0. So take a moment to pause your video and try to find the solutions to this quadratic equation, remembering that you have a squared in your answer, in your problem, so that tells you how many solutions you should have. Pause your video and try to find the solutions. All right, keep in mind that it is possible that you have fraction answers, and that is totally fine. When you have 2x plus 3 equal to 0 and you subtract the 3 from both sides and then divide by 2, it gives you a fraction, and that's definitely fine. Remember to list them from least to greatest in your solution set. Moving on to number 5. Ooh, this does not look like it's in standard form. But I would really like the ax squared term to be positive, so I'm actually going to move these things over here. That way this term can stay positive. So if I subtract 15x and subtract 15x, and if I subtract 50 and subtract 50, well, these will zero out, and I will still have 2x squared minus 15x minus 50. Remember, the minus 15x and minus 50 can't be combined with the 2x squared to make less terms because they're not like terms. They don't have the same variable and exponent. So I notice that there is there's no GCF that I can take out of all 3 of these terms. So I'm going to go ahead and do my magic numbers. And I will go as far as finding the magic numbers with you, but then you're going to finish this on your own. So a times c is 2 times negative 50. That's negative 100. And the b term is negative 15. There are a lot of factors of 100. 1 times 100, 2 times 50, 4 times 25, 5 times 20. Oh, wait a second. Look at that. Look at that. The next one is 10 times 10, but that doesn't really help us. 5 times 20 is 100, and 5 plus 20 is 25, but if I make one of these numbers negative, it should work. Look at that. So take a moment to insert your magic numbers into your problem for the middle term. Factor by grouping and find your solutions. Pause your video and try it out. Okay, go ahead and check your work. I'd like to make a note of some things. So the first thing that I want you to take notice of is that when we split this into 2 groups, the minus sign got put into the second group, and we separated the parentheses with the plus sign. I also want to point out that the second group's GCF was a -10, so that showed up here. And then I also want to point out that I ran out of room, so this bit of work, in order to get to the answer, I had to divide both sides by 2. So we have our solutions off to the side in our braces as our solution set. I also want you to notice that anytime you have a factor that's like x minus 10 or x plus 5 or x minus 7 or something like that, whenever you set that factor equal to 0, your answer for your factor is just the opposite of that number right there. So if x minus 10 is my factor, then 10 is one of my solutions. So that's just a little bit of information that you might want. All right, numbers 6 and 7. 6 and 7, neither one of them are in standard form. So I'm going to help you get them into standard form, and then I'm going to ask you to pause your video and work out the problems and then check. Okay? So on number 6, my x squared term is positive here, so that means I'd like to move these over. The way you move them over is you do the inverse operations, but if you just take the sign that's opposite of what's there when you move it to the other side, then you will have done it correctly. So instead of a positive 28x, if you move it to the other side, it'll be a negative 28x. And instead of a minus 4, when you move it to the other side, it'll be a plus 4. And when I say other side, I mean other side of the equal sign. I'll also tell you that there is no GCF right here. But I do see a perfect square trinomial. So you might want to try that out, because factoring by grouping would give you some pretty monstrous numbers here. In fact, why don't we just do this problem together? So if I square root 49x squared, and if I square root 4, 49x squared, if I square root it, I get 7x. 4, if I square root it, I get plus or minus 2. But this symbol is negative, so I'm going to use the negative. If I multiply 7x and negative 2, I get negative 14. If I double it, I get this middle term. So that tells me this is a perfect square trinomial. I'm going to be able to write this as 7x minus 2 squared, which is really 7x minus 2 and 7x minus 2. So I could rewrite it twice. Now, if I set this factor equal to 0, and I add 2, and I get 7x equals 0 plus 2, which is 2, and I divide by 7 and get x equals 2/7. Well, when I do this, aren't I just going to get x equals 2/7 again? The answer is yes. So is there anything that I need this for? No, it's just a duplicate. It's just a duplicate. So that means that my solution is just 2/7. You do not have to write it multiple times. All right. And then the last one today is definitely not in standard form. So what I'd like to do is move this over and this over to combine with this constant. So I'll have 6x squared. Instead of 11x, I'll have minus 11x because I'm doing the opposite signs. And then instead of plus 2, I'll have a minus 2. And negative 8 minus 2 is negative 10. And I'd like for you to pause your video and try to factor this polynomial. Go ahead and check your work with mine, and you'll have a great day. Bye-bye.